When a tertiary alcohol, such as T-butanol as shown here, reacts with HCl, HBr or HI, a substitution product is formed, in this particular case tertiary butyl chloride, in which the chlorine has replaced the OH group of the starting alcohol. The byproduct is water, and this overall reaction will be described as a unimolecular substitution, in other words the SN1 reaction. The overall mechanism for this process is shown here. In the first step, the OH group is protonated by the powerful acid to give the oxonium species. This then has a water-leaving group which can break away to produce a tertiary carbocation. This will be stabilized by hyperconjugation. It is now flat and easy to attack, and so the halide nucleophile comes in and attacks and gives us the tertiary alkyl halide product. The first step in this process is a fast acid-base reaction in which the basic hydroxyl group is protonated by the powerful HCl, and that gives us the oxonium species. The second step is rate determining. When the water molecule breaks away from the carbon, we end up with a tertiary carbocation. This species is then stabilized by adjacent bonds in the methyl groups. This is hyperconjugation and is best in a tertiary system. You should notice here that this rate determining step does not involve the chloride. The chloride is a spectator ion and only comes into play in the last step. So this rate determining step is then said to be unimolecular. The carbocation is a 6-electron species and therefore reactive. It is flat and easy to attack. So in the last step, which is fast, the chloride behaves as a nucleophile, attacking the electrophilic carbon and producing the 8-electron species as the product. The reaction between a tertiary alcohol and acids such as HCl, HBr and HI produces tertiary alkyl halides. It is understood that the slow step, the rate determining step here, is the formation of a carbocation, and that is then found to be unimolecular. So overall, this is a unimolecular substitution at sp3 carbon, which is described as the SN1 reaction.